So I'm going to see if I can knock this one out really quick. So the first thing I'm going to do here is put this molecule into a staggered conformation. So I'm going to start with this top molecule here, and we're going to do that. I know it's a horrible circle, but if I'm going to the left, counterclockwise, I hit my OH, and my hydrogen is going to be there, okay? And then, so I actually want the methyl group of my red back, this is going to be the red one, to be eclipsed. So I'm going to have it actually up here in the back, and which is this. And if I go counterclockwise, I hit a hydrogen. Okay, and this isn't exact. They usually draw it off to the side, but I'm going to draw it this way. And then I hit the hydroxyl group of this. All right, so what in God's name did I just draw? What is this funky kind of craziness that I'm looking at? Well, I'm going to convert this to blue is actually going to be on the bottom, and red is going to be on the top. Because what I'm going to do is take this compound that I just drew and pull this carbon, actually pull this whole thing downward towards me. And I'm going to stand it up so that it's kind of sitting on these three parts, and the red part is going to be going up in the air, just like this. All right? And really, I'm going to be looking at it from this direction in between these two carbons. So if that's the case, this methyl group is going to be staring right at me. And that was the goal of this entire rotation here. That was the goal of this entire rotation, is to get the methyl groups eclipsed. And I know that in the red, this methyl group is going to be here. And now I can simply just fill in what I drew. This hydroxyl group is going to be on the left. This hydrogen is going to be on the right. And its kind of counterpart, which I drew, is going to be this and is going to be this. So, I mean, how easy was that, right? So now I just need to assign the RNS of both of these. So we'll start with the red, and we'll notice too that with a Fischer projection, this is the kind of little mnemonic we want to remember. If the lowest substituent is not on a hatched wedge, then we switch. So hydrogen is going to get a 4, methyl is going to get a 3, since oxygen is the hydroxyl is going to get the 1, and then this group down here is going to get the 2. So hydrogen is not on a hatched wedge, and when we draw our arrow from 1 to 2 to 3, that's R. So this is going to be the S conformer, or the S configuration up here. Down here, methyl is going to get the 3, hydrogen is going to get the 1, hydrogen is going to get the 4, hydroxyl is going to get the 1, and then this carbon group is going to get the 2. Keep in mind, hydroxyl is getting the first because as we are traveling away, we hit an oxygen first. If we're going this way, we're hitting a carbon first, okay? And comparing this carbon to this carbon is attached to 3 hydrogens, this carbon attached to an oxygen and a carbon. So that's why this one gets a 2. So I just want to make sure that you know that. So if we're drawing our arrow from 1 to 2 to 3, this is going to be going to the right, which would be R, but hydrogen is not on a hatched wedge, so this would be S. So this is S and S, and the answer should be D. And this is for 32. And And the answer is B. What? The answer is B, RR. What the heck did I do wrong? Oh, you know what? I think I want to sit this. If I do it this way, these groups are coming towards me. The methyl groups are coming towards me. I want to push this backwards so that blue is on top. That's what I want to do. Kind of glad I got this wrong. This is how quickly you get confident with this stuff. And then you get screwed. Right. I want the methyl groups to be eclipsed but going away from me. See, I forgot to visualize this. So when I build this tower, I want the red to be on the bottom. So my methyl group would be here. This methyl group would be here. And if I'm looking at it this way, the hydroxyl is going to be over here with the hydrogen here. This is going to be like that with this here. All right, so now let's redo that. 3, 4, 1, 2, 1, 4, 3, 2. If I go 1, 2, 3, S, that's going to be R. And if I go 1, 2, 3, left S, that's going to be R. So there you go. So that's how you get a problem wrong, realize why you got the problem wrong, and learn from your mistakes. If I had made the model for this, I would not have gotten that wrong. It's impossible to get it wrong with the model. So there's how you do it. Cool. That's a good learning experience, right? Getting something wrong like this and then realizing why. That's what really makes this stuff stick. And this is a really interesting, wrapping your head around the difference between these molecules is really an interesting thing, because you have to remember that even if I built the model for this SS and turned it on its head, I'm not going to get this, right? These are a pair of enantiomers. So, very cool.